Problem 4.121. Problem 4.121 in the 14th edition. Okay, so what we have here is we have this beam. We've got these forces, 450 at this angle of 60. We've got 300. We've got a force of 700 at an angle 30. And we have a clockwise couple moment of 1500. Okay? And we got these specific lengths here. Okay? So 121 says replace the loading acting on the beam by a single resultant force. Specify where the force acts measured from end A. Okay, so I now wrote down 122 here. Just waiting for it to focus. Okay, this should be 121. Problem 4, 121 in the 14th edition. Okay, so here's the beam. Just try to redraw it here. Okay, so remember, in chapter 4.8, what we're doing is we are further reducing a force and couple system to a single force acting somewhere along the beam. Okay? And what is the criteria, guys? What is the criteria for further reducing? It is to have our resultant force perpendicular to our resultant couple moment. You must have this criteria. If you do not have this criteria, you cannot further reduce the system to a single force acting somewhere on the body. Okay? So, what is the first step? First step is let's calculate our resultant force. So, resultant force in the x, sum of the forces in the x, which is equal to 450 cos 60, and this is 700, this force here is 700, minus 700 sine of 30. Okay, and this gives us minus 125 Newton. That's the resultant force in the x direction. Then the sum of the forces in the y is equal to minus 450 sine 60 minus 300 minus 700 cos 30, and that gives us minus 1295,93 Newton. Okay? Then our resultant force is equal to that squared plus that squared, which gives us that's Pythagoras. That squared plus that squared, square root. Okay? We know how to do that. Should give us that. We've got our resultant force of 1301,9, and we need to determine the angle. We know that we've got 125, and we've got 1295,93. Okay? And yes, so this is our FR, 1301, and this angle here is calculated as 84,5. Okay? I'm not going to go through all of that. That's just straightforward tan to the minus 1 of 1295,93 over 125. Okay? So now we've got our resultant force, and we've got the direction of that. Okay? The next thing is, remember what we're trying to do. What we would have done before is we would have calculated our resultant force, placed it there, and then determined all the moments due to those forces, plus the existing couple moments. There's nothing new here, right? We still want to say counterclockwise is positive, resultant moment about O, or rather in this case about A, okay, is the sum of all the moments about A. Okay? Now, there's a specific thing here which I just want to quickly discuss, and I'll come back to this equation here. we've taken all those forces, and at point A, we have replaced it with a single force, which is 1301,9 Newton at a specific angle of 84,5. Okay? Now, what we want to do is we want to move this to some point on the beam so that, remember, all these forces, right? All these forces add up to this. We apply it at that point, but then we need to include all the couple moments due to those forces, plus the existing couple moments, right? So you're going to get some kind of couple moment here. I'm not sure if it's clockwise, or well, obviously it's going to be clockwise, okay? Because all the forces here are causing clockwise moments, all right? So this is what we would do before. We would get the force and we would get a moment, and that would be an equivalent system to the original system. But what we want to do is we want to change this force and couple system into a system that just has that force, this force, acting somewhere on the body. Okay? Again, remember what we did before. If you have a force here, that force, we can replace that force with a force and a couple moment acting at that point, or we can reverse it. We can reverse this force couple system to a single force acting on the body. Well, that's exactly what we want to do here. We have a force and a couple, all right? We haven't calculated the couple, but it's there. We haven't done it yet. And we want to replace it by a single force, this force acting somewhere on the body, okay? So the equation then is the resultant moment about point A is equal to the sum of the moments. Okay? So if we want to take this force and put it at some point here, so that force acting there is going to give us the same effect as a force in a couple. That force is going to cause this body to translate and rotate, right, about that point. I hope that's clear. So on the left-hand side, we have the resultant couple moment about point A. Okay, and on the left-hand side, we have the sum of all the moments, all the couple moments. So this on the left-hand side is essentially the resultant force times a perpendicular distance. It's this force times a perpendicular distance about A. And on the right-hand side, we need to sum up all the moments due to all these forces and the existing couple moments. Okay? So it's very simple. The resultant couple moment, which is due to this force acting at some point, right, times a perpendicular distance, should equal the sum of all the moments acting on the body due to the forces and the existing couple moments. Okay, so I'm just going to do that like that. Okay? But now, what I want you to note here is that this force here is you can break up into its F, that one, let's call it F vertical, and F horizontal. Okay? Now what you notice is that this is using the principle of moments, right? The moment of this force about that point is equal to the sum of the moments of the components. So that force, as you can see, does not cause any moment about A. So on the left-hand side, in this case, all we're interested in is using this FV and finding this perpendicular distance. Okay? So if we simplify this, we are only going to need this vertical component of the force multiplied by a perpendicular distance. Okay? So let's call it this F, let's call it Fy, all right? Fy times this D is then equal to the sum of all the moments due to these forces. So the first one we're going to have is going to be 450 sine 60. That's going to be the vertical one, times the moment arm, which is 2. And that vertical component is going to cause a clockwise rotation. So we have 450 sine 60. That's the magnitude. And our moment arm will be 2. And is that force there going to cause a clockwise or an anti-clockwise rotation? It's going to cause a clockwise rotation, so it's minus, right? Because we've said clockwise, anti-clockwise is positive. And then the horizontal component of this force is passing through A, so there will be no moment. Then we need to include the moment due to this force, which is minus 300 times 6. And the reason I'm saying minus 300 is not because it's going in the negative y direction. It's because the 300 times the moment arm of 6 will give us a clockwise rotation, which is a negative moment. Then we need to include this one, 700 cos 30 times 4 plus 2 is 6 plus 3 is 9. 700 cos 30 times 9, and it's causing a clockwise rotation, which is negative. So it's minus 700 cos 30 times the moment arm of 9. And we need to then also include minus 1500 Newton meter. So what is this Fy on the left-hand side? This vertical force is just simply the Fy here, which was 1295,93. So we've got 1295,93 times d, this d here, and that force there is causing a clockwise rotation about point A, so it must be a negative moment. That's from the previous one there. And then, so this 1295,93 is this Fy, d is this perpendicular distance, and the minus tells us it's a clockwise rotation. And this on the right-hand side gives us minus 9535,38. So if we solve for d, we get 7,35 approximately. 7,35 meters. What does that mean? It means that if I take this force and I move it this distance d and I apply it there at 7,35 from A, that's my d. D is 7,35. Then, and I apply that force at that point like that, it is equivalent to this force and couple system, and it's equivalent to this force and couple, this system over here. So this is equivalent to this, although we never calculated what that couple was, and is equivalent to this. Okay? Provided, you can only do this provided you are working in a coplanar system or a parallel system, where the forces are either coplanar or the forces are parallel. Okay? And this system we were looking at is a coplanar system, because the forces will be perpendicular to the couple moment. Okay? So, hope that helps. Cheers.